In this video, let's learn about Chebychev's inequality. Okay, this is a very important 5 mark that you can see in measure and integration paper. So, let's start with the statement. Here you can see the statement of Chebychev's inequality. Okay, let's learn using my notes. Let f, here you are having a function f and this function is non-negative and measurable function, okay, and this function is on the set E. Then if that's so, then for any lambda greater than 0 there is a lambda and that lambda will be greater than 0. Measure of the set x belongs to E such that f of x greater than or equal to lambda will be less than or equal to 1 by lambda integral f over E. Okay, this is what the statement, that is what we are going to prove this inequality. So proof, let E lambda, you are taking this set, okay, as E lambda. Let E lambda is equal to set of all x belongs to E such that f of x greater than or equal to lambda. You are splitting the proof of this theorem into two cases. That is, in case 1 you are taking measure of this E lambda equal to infinitive, and in case 2 you are taking measure of this E lambda is less than infinitive. That are the two cases. Now in case 1 you are defining something, that is E lambda comma n is equal to E lambda intersection closed interval minus n comma n. It means you are taking the value of E lambda comma n will be equal to the intersection of these two values. Okay, that is how you are defining. So from this you are writing when you find E lambda comma 1, that will be the subset of E lambda comma 2, and that will be the subset of E lambda comma 3, and so on till infinitive. And then union n is equal to 1 to infinitive E lambda comma n, all the E lambda comma n values is equal to E lambda. The union of all E lambda comma n values is equal to E lambda. Okay, that is how, okay, you have to write. Now you are taking measure on both sides so that you will get measure of E lambda is equal to, you are right, instead of writing union n equal to 1 to infinitive, you are writing limit n tends to infinitive. Both, the meaning of both are same. Limit n tends to infinitive, measure of E lambda comma n. And from here you are writing that we know that f is measurable. From the statement itself we have f is non-negative and measurable function on E, right? So you are using that here. Since f is measurable, you can say this E lambda is also measurable. If E lambda is measurable, then what you can say, from this E lambda comma n will also be measurable. That is how you are writing here. Now you are taking, let psi n is equal to lambda into chi of E lambda comma n. Okay, you should not forget. Okay, if you forget this, you could not proceed this proof. Let psi n is equal to lambda into chi E lambda comma n. That is how you are taking the value of psi n, and then you are writing then 0 less than or equal to psi n less than or equal to lambda, lambda less than or equal to f of x. Have to write this. Now let infinitive is equal to lambda m of E lambda. This also you should not forget. Infinitive is equal to lambda m of E lambda. Okay, because m of E lambda tends to infinitive, so even if you multiply that with lambda, that value will also be tends to infinitive. So that is why infinitive is equal to, you are taking, to proceed further you are considering like this, infinitive is equal to what, lambda into m of E lambda. So from this you can substitute the value of E lambda here, and from this you will get limit n tends to lambda into m of E lambda comma n is psi n. So you are writing lambda into measure of E lambda comma n, right? So you are writing with integration. Integral psi n over E. From this you can write less than or equal to, we know that psi n is less than or equal to f of x, right? That is why here you are writing less than or equal to, write this integral over f, and in the place of psi n put f. The reason is because psi n is less than or equal to f of x. That is why. From this you can write integral f over E is equal to infinitive. So even when if you multiply this with 1 by lambda, the value will also be equal to infinitive. That is how you are writing this. Now measure of E lambda is equal to measure of, substitute the value of E lambda here. This is equal to infinitive. How? That is what our case 1, right? M of E lambda is equal to infinite. This is this is E lambda value, that is equal to infinitive. We know the value of infinitive, this. So just put that value. So you have proved our inequality in case 1. So let's consider case 2. In case 2, measure of E lambda less than infinitive. So here you are taking h is equal to lambda into chi of chi E lambda, not of, chi E lambda. So you have to keep these two in mind. At the time of studying itself, you have to identify the differences between these two and differentiate it in your mind. Okay, where you have to write what, and okay, that like that you have to differentiate it. Then only when writing examination we don't get confusions. So here psi n you are defining, here you are putting h. Psi n is equal to lambda into chi E lambda comma n. This h is equal to lambda chi E lambda. So here h is a bounded measurable function having finite measure. Okay, having finite measure, 0 less than or equal to h, less than or equal to f. That is, here you are writing psi n. Below to psi n you are writing inequality, right? Similarly for this h also, after defining h, here also you have to write inequality, right? So that is why you are bringing finite support here. H is a bounded measurable function of finite support. 0 less than or equal to, by the definition of finite support you are writing this, 0 less than or equal to h, less than or equal to f. Now you are let lambda m of E lambda is equal to lambda into m of E lambda is equal to lambda into, in the place of m of E lambda you can write integral chi E lambda over E. Now bring this lambda inside so that you will get this. So in the place of lambda into chi E lambda you can put h, right? Lambda into chi E lambda you can put h. So that is why here you are putting. This will be less than or equal to integral f over E. The reason is because h less than or equal to f, right? So that is why in the place of h you are putting f with this inequality. And now you can write the left hand side and right hand side. From this, if you find the value of m of E lambda, then you will get less than or equal to, lambda will come to this side, so it will become 1 by lambda integral f over E. So from this m of, in the place of E lambda, just substitute the value less than or equal to, write this as it is. Hence you have proved the inequality, Chebychev inequality in 2 cases. Hence the proof.